Today's video is on lesson 4.5, using congruent triangles. So far we've talked about how to write that triangles are congruent. So now that we know triangles are congruent, we're going to look and see what we can then prove knowing that we have two congruent triangles. So the first theorem that we have says if two triangles are congruent, then their corresponding parts are congruent. And so we abbreviate that by saying CPCTC, which stands for corresponding parts of congruent triangles are congruent. So basically, if we know that we have two congruent triangles and we have proved that they're congruent, then what we can do is show that two of the angles are congruent to each other or two side lengths are congruent to each other. Um, and so remember, in order to prove triangles are congruent at this point, we only need to have three things, either angle, side, angle, or angle, angle, side, 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 angle, side. And so using CPCTC allows us to prove that something different is congruent in those triangles. So let's look at how this is going to work. So we have here something that looks like it could be a parallelogram. We don't know right now if it is or not. So we look at our given pieces of information and we know that HJ is parallel to LK. And so I've drawn that on my picture. And then we know that JK is parallel to HL. So I've also indicated that on my picture. And ultimately, what we're trying to prove is angle LHJ is congruent to JKL. So those large angles at point H and K are congruent to each other. So we start with our given information. We start with our two parallel lines, and then I started by saying that JL is congruent to itself using the reflexive property. You don't have to start there, as we've talked about in class. You can start with, something different. And then from there, I noticed that angle HJL is congruent to angle KLJ because alternate interior angles are congruent to each other. And I can also say the same thing for the other angles at both at both L and J. So I can also say that HLJ is congruent to KJL. Both of those are also congruent by alternate interior angles. So knowing that we have parallel sides allows us to know that there are alternate interior angles that are congruent. So then I can say that those two triangles, LHJ and JKL, so the two smaller triangles there on the left and the right of that transversal, are congruent to each other because of angle side angle. Now, once I prove that, now I know that all the matching parts of those two triangles have to be congruent to each other. And that's using CPCTC. Corresponding parts of congruent triangles are congruent. So once I know that the triangles are congruent, then I can say that those two angles H and K are congruent to each other. Without knowing that those two triangles are congruent, I have no way of proving that angle H is congruent to angle K. So that's why CPCTC comes in handy. All right, let's look at another example. I have this kind of crazy shape here, and I am given a bunch of information, and I need to prove that triangles QUV and QSR are congruent to each other. So I think once you draw in all your given pieces of information, and then use CPCTC to prove that two of the sides of two of the triangles are congruent to each other, then you'll be able to prove that those two outer triangles, if you will, are congruent to each other. So I'd like you to try that problem on your own. Do as much of it as you can tonight, and we will definitely go over that tomorrow. Again, you're going to need to prove that the two inside triangles, so these two triangles that are made up with a QT, are congruent to each other. Then use CPCTC to prove that two of the other sides are congruent to each other, and then that should give you enough information to prove that those last two triangles are congruent. So go ahead, try that for tomorrow. Enjoy your night, and I'll see you tomorrow.